Okay, good morning, it's FY here. So today we're going to learn the lessons of analysis function when the function f is polynomial. Okay, so please make sure that you have this flowchart before we begin with the example. We're going to use this flowchart as our guideline to answer the question in the example. Okay, let's just look at the example that we have. Okay, let's look at this example. Okay. In example 1, we are given a function f, okay, that is equal to x cubed minus 6x squared. The first question that we have here is they are talking about the x-intercept and y-intercept. Okay, let's just begin with the x-intercept. Okay, if we are talking about the x-intercept, basically it means that we have to let the y equal to 0. Okay, if you look at your functions in here, okay, what is your y here? So basically your y is your function fx, okay? So we have the function fx that is equal to x cubed minus 6x squared. So what you have to do is you just let the y, that is x cubed minus 6x squared, equal to 0, okay? You just take this one and let it equal to 0, then we have our x-intercept. Okay, this one you can factor out the x squared. So when you factor out the x squared, what we have here is we have x minus 6 equal to 0. And then the result will be the x will be equal to 0 and x will be equal to 6. That is our x-intercept. Okay, what happens to the y-intercept? Okay, let's just look at the y-intercept. Okay, y-intercept means that you're going to let the x equal to 0. Okay, so let's just let the x equal to 0 into this function f. Okay, so this is your function f. Okay, so now you have f and f0. Okay, f0 equal to 0 cubed minus 6, 0 squared. Okay, and basically this f0 will give you 0, okay? And y is actually equal to your result of f0. So your y is actually equal to 0. That is your y-intercept. Alright, okay, let's just go for the real part that we're going to learn today. That is, we are talking about all critical points of the function f, okay? So how are we going to find the critical point of the function f? Okay, let's just look back on the flow chart that we have. Okay, this is the flow chart that we have. Okay, the first thing that you should do is, now we're talking about the critical point. The first thing that you should do is you go to find the f prime and you let the f1 equal to 0. Then you got your x from here. Okay, once you have the x from here, then you need to find the y. And then the x and y will form the coordinates for the critical point. Okay, let's just begin with how to do it, okay? So let's look at the second part. Okay, let me push it up a bit. Okay, I need the function. Okay, so B, the part B. So we'll be given the functions of f x equal to x cubed minus 6x squared. The first thing that you should do is you find for the f prime. Okay, so f prime means that you have to differentiate with respect to x. So in here, what we have here is x cubed squared, x 3x squared minus 12x. Okay, that is what we have for the f prime. So according to the step that we have just now, we have found the f prime. The next thing is let the f prime equal to 0. Okay, so let's just let the f prime equal to 0. So we let f prime equal to 0. So if we let this one equal to 0, so we'll have 0 equal to 3x squared minus 12x. Let me push it out a bit, right? Okay, so right, okay. So in here, when you factor, okay, so when you factor out, you can factor out basically the 3 and the x from here. So we have x minus 4, and at the end we have x equal to 0 and x equal to 4. Okay, so that is the x from the f prime equal to 0. Okay, the next thing that you should do is, okay, you already managed to get your x. Okay, then you let your y equal to fx. Okay, so what does this mean? Okay, so when we have to answer, right, for the x, so we have when the x equal to 0, so you let y equal to fx. Your x now is 0, so do the substitution into here. So we have 0 cubed minus 6, 0 squared, so this actually gives us equal to 0. So from here, you have one coordinate, okay, one coordinate. Okay, so that is 0 and 0. So this is the first critical point that you get, okay? And then we have another x, okay, that is when x equal to 4, okay? So now, same thing, we're going to repeat the same process. You let y equal to function fx, okay? Now, what is your x? Your x is 4, okay? Your x is 4, okay? And then we sub it in here, so you will have 4 cubed minus 6, 4 squared. And this basically give you minus 32. So you have the second coordinates that is actually 4, 32. Okay, so these two are the critical points that we are looking for. Okay, so the critical point. So the first critical point that you have is this one, 0, 0, 0, 0. And the second critical point that we have here is actually this. It is 4, negative 32. Okay, so we have done on the part B, okay, finding the critical point of the function f. So now we're going to look at the interval where the function is increasing or decreasing. Okay, in order to answer the question of increasing, interval of increasing or decreasing, then let's just move to this guy. Okay, so we have done with this critical point. So it says that you need to use the x from the critical point to form an interval table. Okay, so let us form the interval table from the critical point. Okay. So B of C, part C, right? Okay, so now, okay, you need to form an interval table. Okay, that interval table is basically using the value that is coming from the critical point. Okay, so what you have here is you have the value of 0 here. Okay, you can put it here. Okay, and you have the value of 4 here. So, okay, we follow by the real number. Okay, the real number line. So 0 comes first. So we have 0 here. We have 4 here. We just use the x from critical point. Okay, so from here, you can form an interval. Okay, you can form interval for each column. Okay, so for the first, okay, I'm going to do this one first because this you have 0 and 4, and this basically is an interval of 0 and 4. Okay, okay, it's between two numbers, right? So you have an interval form like this. Okay, but for the front, okay, so what we have here is you only have the number of 0. So you only have 0 here. And in here, it must be a negative infinity. Alright, okay. So for this part, we only have 4. So we have 4, and then it must follow by a positive infinity. Okay, so that is the way that we write the interval. Okay, the next thing that you have to do is you should consider a test value that is 4 in each category. A test value 4 in each category. If we look at this interval, okay, in this interval, okay, so you can use any number in between this interval, okay. For instance, you can use, let's say, -5, -1, okay, any number that is 4 in this interval, okay. Usually I will pick the most easy for us to check, Okay, the most easy number to check the the first derivative test. Okay, so then this one is you can choose any number. You can choose 1, 2, 3. Okay, which is within this interval, but don't take the exact number. Don't take the exact number as 0 or 4, because the 0 it could be either is actually in the middle. So this is actually not helping us to identify the interval if you pick the 0. Okay, so pick the number which is within, exactly within this range. Okay, so we will have, let's say I'm putting 1 here. Okay, the same thing. Okay, I will take 5 for the test value. Okay. The next thing that you should do is you're going to check the sign of f prime. What does it mean by the sign of f prime? Okay, it means that you're going to substitute. Okay, you're going to substitute the test value inside here. Okay, so what we have here is, okay, now we have the f. Okay, for instance, I have f prime. Okay, so I'm going to substitute -1 into my f prime. Okay, so that is here. So you have 3 minus 1 square minus 12 minus 1, and use your calculator to get the value. Okay, so okay, as a result, you have some answer. Okay, the answer is actually, okay, you have 3 plus 12, that is actually 15. Okay, so the 15 is a positive number. We do not interested to know what is the exact value when you substitute the x minus 1 into here, but we just want to know the sign, that is a positive sign or is a negative sign. So for this case, we have a positive sign. Okay, and let's say, how about this? Okay, so same thing. So we're going to substitute the x equal to 1 into f prime. Okay, so let's just see that we will substitute. So same thing we will refer to here. So we're going to substitute in here. So we have 3, 1 square minus 12, 1. Okay, so this gives you minus 9. Right? Okay, so we have minus 9. So that minus 9 is actually a negative value. It is a negative value. So means that we are interested to do the sign, and the sign here is negative. So put a negative. Okay, so you're going to work the same for the f prime. Okay, you take the test value, that is 5. So you substitute into your calculator, substitute into these functions, and in the end it will give you a result of a positive value. A positive value. A positive value. We do not interested to know the exact figure of after you substituting. Okay, we just want to know the sign. So this one is actually a positive value. So just put a positive here. So after that, okay, this is erase those things. We don't need it anymore, right? Okay, let's look back on the flow chart. Okay, so the flow chart says that, okay, if you are getting the sign of positive value, so means that is the interval of increasing. If you get the f1, that is interval of negative value, that is interval of decreasing. But if you get the f1 equal to 0, means that is a stationary point. Okay, so just now, according to our table, just now we have two signs. One is positive value, and another one is negative value. So we will say that the positive value will be the interval of increasing, and negative will be the decreasing. So let's just go back to the table that we just did it just now, right? Okay. So this table, so you can see that this is interval of increasing, this is interval of increasing. Okay. So let us write the conclusion. So interval of increasing, that we have two intervals. The first is that this one, that is negative infinity until 0. So we have negative infinity until 0. Okay, the next increasing interval, that is 4 in this, that is from 4 to infinity. So we have 4 to infinity, that is the interval of increasing. Okay, because we have two different intervals, so join them with an union sign. Alright. Okay, the next will be the interval of decreasing. So the interval of decreasing, that is 4 in here. So that is 4 in here. So that is the interval of 0 to 4. Okay, so we have 0 to 4. That is our interval of decreasing. Okay, so the next things that we need to find, that is the relative extremum. Okay, so let's look at the relative extremum. So we're talking about relative extremum point. So if we're talking about relative extremum point, so that could be a relative maximum or relative minimum. Okay, let's just go back to the flow chart one more time, right? Okay, so in here, let's just look at the flow chart. We have done with this. Okay, so we go for the flow chart. Okay, so then we go for the relative extremum. So this time you need the information of f double prime. Okay, f double prime, and this will help you to get to identify whether the critical point that is maximum or minimum. Okay, so we still need the information of critical point. Okay, we're going to use the x from the critical point, and we're going to use the information of f double prime in here. Okay, let's just go back to the screen. So in here, okay, first of all, just now what we have is we have that, okay, f prime. Okay, just now f prime, okay, we just did it, that f prime is 3x squared minus 12x. Just now we did it. Okay, so now go for f double prime first. Find for f double prime. So this one, okay, if you differentiate one more time, what we have here is you have 6x minus 12, right? So once you get that, okay, the next thing is let's just go back to the critical point. So that the critical point, we have 2, 0, 0, and 4 comma, okay, minus 32. Okay, so let's just test on this one. Okay, so let's just test on the first critical point that we have here. So we have the critical point on 0, 0. Okay, so now we're testing by second derivative. So we have this f double prime. Okay, just use the x value that you have here. So you substitute here and see what happened. Okay, so we have 0 here. So you have 6, 0 minus 12. So the result is minus 6. So minus 6 is actually less than 0. Okay, if that way, okay, it means what is, let's just go back to the flow chart one more time. So now you have a case of f double prime less than 0 means that it is a maximum point. Okay, so it means that this 0, 0 is a maximum. Okay, then we have a second critical point. So let's look at the second critical point. Or let me write it here. So critical. So the second critical point, we have 4 minus 32, same thing. Okay, so we're going to substitute our 4 into the f double prime in here. So we will have f double prime 4. So we have 6 multiplied with 4 minus 12. So the answer is actually 12. Okay, sorry, the answer is actually 6. Okay, oh sorry, it's correct, it's 12. Okay, so we have 12. Okay, so then, okay, 12 is a value that is greater than 0. Okay, so let's just look back on the flow chart one more time. So in here you have f double prime greater than 0 means that that point is actually a minimum point, right? Okay, so instead 4 minus 32 is a minimum. Right, okay, so we have done with the part of the relative extremum. Okay, so the last part of this question, that is they ask you to sketch the graph. So if they ask you to sketch the graph, there are a few things that you need to know. Okay, the first thing that you should have is the x-intercept and the y-intercept. Let's just go back to the x-intercept, y-intercept. Okay, we need the information of x-intercept and y-intercept. That is this one, and this is the one. Okay, and we need the information of the y-intercept, and we need the informations of the maximum point and minimum point. Maximum point and minimum point. So that is this one and this one, right? Okay. Okay, let me take it out. Let me take it out the point that we have. We have the x-intercept. The x-intercept that is x equal to 0, x equal to 6. And we have y-intercept that is y equal to 0. And we have the point here. Okay, so first thing that you have to do is let's just sketch the let's just draw the axis. Let's just draw the axis. Oh. So we have here y and x. Okay, so if you look at the value of x-intercept, the x-intercept that we have here is actually 0. That is here. Okay, the other x-intercept that we have here is 6. Okay, so we have a 0, we have a 6 for the x-intercept. Okay, and then for the y-intercept will be y equal to 0, is still here. Okay, and the next information that we look at is the critical point. Okay, in here we have maximum point 0, 0, it's still here. Okay, another critical point we have is 4 and negative 32. So x is 4, so we'll just put it roughly here. Okay, and we have negative 32 somewhere. I'll just roughly put the coordinates. So we have here 4, negative 32. So just now this is 0, 0. So that 0, 0 is a maximum point, and this one is a minimum point, right? Alright, okay, so we have an intercept here, and intercept here. Okay, so in order to draw correctly, okay, so I'm going to use the table of the interval of increasing and decreasing. Alright, okay. Let me cut this. Okay. Alright, okay, so let's look at the interval of increasing and decreasing. Okay, so if we're talking about the interval of increasing, that this is the positive sign. It means that, okay, your graph should be going up. The graph should be going up from the interval from negative infinity until 0. That is the range from here, so it should be going up. So let's draw it. Okay, so we have this is negative infinity here to 0. Okay, so instead you're going to draw it. So we're going to, okay, let me push it. Okay, so let me draw it. Okay, so we have going up, right? Okay, so then we have 0, 0 to 4. We should see a 0 to 4. That is an interval that is going down. Okay, because it's decreasing. So you have follow the train. So that is actually a smooth curve that is going down, right? Okay, this curve somewhere here. Alright, okay, and then you have a 4 to positive infinity, and that is a curve of going up. Okay, it's curve of going up. Okay, so same thing, 4 to infinity. 4 into infinity is 4, this is 6, and we have infinity here. But be careful when you draw that, okay, because we have the x-intercept. Okay, our x-intercept that is 6 just now. Okay, x-intercept. Okay, let me use the color to highlight it. This x-intercept, and y. This is the x-intercept. So make sure that the curve that you draw going up, it should pass through. It should pass through the 6, the x-intercept here. Okay, So means that continue the graph, the curve by going up like this. Okay, so you can see that the range from 4 to the infinity is basically going up as this one. Okay, and it must pass through the x-intercept x equal to 6. Okay, and this one is passed through the x-intercept 0. Okay, and okay, that is the solution for the example 1. Okay, and then you can see that it is 0, 0 is the maximum point, and in here is the minimum point. You can judge from the pictures. Okay,